right, welcome back, mathematicians. So what I want to do is go through the review that you just completed and show you some strategies that you can use in order to answer these questions. So make sure you're paying attention because you guys have your exam tomorrow, and I can guarantee you're going to see questions that are either exactly like the questions you're seeing now or very similar. All right, so here is our first question. So we've got Jerry. He has a new job and earns a salary of $45,000. Victoria has a new job and earns a salary of $54,000. Jerry will receive a salary increase of $2,500 per year, and Victoria will receive a salary increase of $1,500 per year. Which equation can be used to find X, the number of years it will take Jerry to earn the same salary as Victoria? Okay, and then we've got a list of equations here. All right, so the first thing we want to do is figure out what it is we're comparing, right? So I know that we've got Jerry and we've got Victoria, okay? And our question says, which equation can be used to find X, the number of years that it will take Jerry to earn the same salary as Victoria? So there's that keyword same. So that tells me that whatever Jerry makes, so I'm gonna use a J to represent Jerry, has to be equal or the same as Victoria, okay? So now let's fill in what we know about Jerry. Well, Jerry, he has a job that earns $45,000, okay? So we know Jerry earns $45,000. Victoria has a new job and earns a salary of $54,000. Okay, so Victoria earns $54,000. Okay, Jerry, all right, so Jerry will receive a salary increase. That tells me that we are adding, right? So I'm got to add something to this of 2,500 or 2,500 per year. Here's that word per. Okay, anytime I see per or each, that tells me I am multiplying, right? So I'm taking that 2,500 and I'm multiplying it by the number of years. Do we know the number of years? No, that's our variable, right? Our X is the number of years. So I need to add 2,500 and multiply that by the number of years. So we're going to use X to represent the number of years. So for 45,000 plus 2,500 times X is equal to, all right, so Victoria, she earns 54,000, and then she's going to earn a salary increase. So here's that word increase again, which tells us that we're adding 1,500 per year. So we need to take that 54,000, add the 1,500 per, which tells me I am multiplying. So I need to take that 1,500 and multiply it by the number of years. All right, so here's our equation. For 45,000 plus 2,500 times X is equal to 54,000 plus 1,500 times X. And so if I look, the answer choice that matches our equation is H, or C. All right, so here is number 2. So Veronica is ordering trophies for her school. Company P charges $3.50 for each trophy and a one-time engraving fee of $25. Company R charges $7.50 for each trophy and a one-time engraving fee of $17. Which inequality can be used to find X, the minimum number of trophies that can be ordered, so that the total charge at Company P is less than the total charge at Company R? So this is very similar to question 1. However, instead of writing an equation, this time we're writing an inequality. So again, the first thing we want to do is figure out what it is we're comparing here. So I can see that we've got Company P, right, is being compared to Company R. All right. And then if I go to the last question, it says the total charge at company P is less than. All right, less than. I know that my inequality sign for less than looks like this. So company P has to be less than company R, right? All right, so let's see what it says about each company. Well, we know that company P charges $3 for each trophy and a one-time engraving fee of $25. All right. So what's our variable going to represent? Well, we know, again, if we look at that question, our variable is going to represent the minimum number of trophies. All right. So our number of trophies is our X. So our variable, actually here, so there's no confusion. I'm going to write it up here. So our variable, our X, is the number of trophies, right? Okay. Well, if I go back to company P, I can see this $3.50 for each trophy. Again, here's that word each. That tells me I'm multiplying. So I need to multiply that $3.50 or 3.5 times the number of trophies, which is our variable. 3.5 times X, or 3.5 or $3.50 times the number of trophies, and a one-time engraving fee. Here's that word fee. All right, anytime I see that word fee, that automatically tells me that's my constant. Okay, that's the number I'm adding or subtracting. So are we adding or subtracting that 25? Well, I know to get the total cost, right? To get the total charge, I need to add my prices, right? So we need to add the $3.50 for each trophy plus the $25 engraving fee, okay? And that's all we know about company P. So let's do the same thing for company R. So company R charges $7.50 for each trophy, or 7.5. Again, each, that tells me I'm multiplying. So I need to multiply that 7.5 times the number of trophies, or times X. Okay. And then a one-time engraving fee of $17. So again, to get our total, we need to add that engraving fee. And again, we need all of our charge for company P to be less than, right? Less than all of the charge for company R. So let's see if any of these inequalities match what we just wrote. Well, again, if I look at the third choice, H or C, I can see that this inequality, 3.5 times X plus 25, is less than 7.5 times X plus 17. All right, let's keep rocking and rolling. All right, so at a store, each notebook has a cost of X dollars. Which situation can be represented by this inequality? So here is our inequality. All right, so I have 5 times X is less than 3 times X plus 2. All right, so X is the cost of the notebooks, right? Notebook has a cost of X dollars. We don't know the cost of the notebook. That's our variable. That's our unknown value. So we need to take the 5, multiply it by the cost of a notebook, right? And it needs to be less than 3 times the cost of a notebook plus 2. All right, now this question should look familiar. You guys have seen this before. So I'm not going to spend a whole lot of time on this one. If I look at C, all right, so C says the cost of 5 notebooks. So 5 notebooks, so 5 times the cost of 1 notebook, right? So that's how I would get the total cost of 5 notebooks is less than, that matches the cost of 3 notebooks. So again, I'm taking that 3 and multiplying it by the cost of a notebook, right? Plus, right, that tells me I'm adding a $2 pen. So 5 notebooks times the cost of a notebook is less than 3 times the cost of a notebook plus 2. All right, number 4. All right, here's a bunch of words. Let's look. We got an equation. It says which situation can be represented by this equation. So here is our equation. Our equation says 7 times x plus 1 is equal to 10 times x. So we need to pick the situation that matches that equation. All right. So let's look at answer choice F. So F says Brody ran a constant rate of 7 miles per hour in a race. Candace ran a constant rate of 10 miles per hour in a race and started 1 mile in front of the starting point. What is X, the number of hours that Brody and Candace would have to run in order for their distance to be the same? All right, so down here, I'm going to write an equation that matches this situation. So again, we're comparing Brody to Candace. They need to be the same, right? Here's that word, same. All right, so what do we know about Brody? Brody ran a constant rate of 7 miles per hour. Again, here's that word per, right? That tells me I'm multiplying. So I need to multiply that 7, right, times the number of hours. Do we know the number of hours? No, that's our variable. That's our unknown. So I'm going to take that 7. I'm going to multiply it by x, or the number of hours. Okay, do we know anything else about Brody? Looks like that's it. So now let's move on to Candace. All right, so Candace ran at a constant rate of 10 miles per hour. All right, so 10 miles times the number of hours. And she started 1 mile in front of the starting point. Okay, so we need to figure out whether we're adding or subtracting that 1 mile, right? Well, in order to get the total distance, right, we want the total distance to be the same. So to get the total distance for Candace, we need to add that 1 mile, okay? So Brody, which is 7 times x, or 7 times the number of hours, needs to be equal to 10 times x plus 1. Does that match our equation? It does not, so our answer cannot be F. All right, so now let's move on to answer choice G. So if I look at G, G says Brody played a game where he scored 8 points per hour. Candace played the game and scored 10 points per hour. What is X, the number of hours that Brody and Candace would each have to play the game in order for their scores to be the same? Now, if I look at my equation, again, all we're doing is writing an equation. I'm not solving anything. So I know right off the bat, if I see this 8 points per hour, nowhere in this equation do I have an 8. So I'm not even going to waste my time writing this equation, right? Because if my equation doesn't have an 8 up here and I'm trying to match it, I know for a fact it can't match because I'm going to have an 8 in this equation, right? So I'm going to go ahead and cross out G. All right, so let's move on to H. H says Brody went to 2 different amusement parks. The first park charged $7 per hour and gave a 1% discount for showing a student ID. The other park charged $10 per hour. What is X, the number of hours that Brody would have to stay at each park to have to pay the same amount? All right, so again, we're comparing Brody, right? So B. Oh, actually, I messed up. We're comparing 2 parks. We've got Park 1 and Park 2. I apologize. So we've got Park 1 and Park 2, right? So the first park has to be equal to the second park. All right, so what do we know about the first park? Well, we know the first park charges $7 per hour. Do we know the number of hours? No, that's our variable, right? So if I look at that last question, X is going to represent the number of hours. So somewhere for Park 1, I'm going to have a 7 times X, or times the number of hours. Now, here's where we need to pay attention, because it also says it gave a 1% discount for showing an ID. All right, so there's a couple ways I know that this is incorrect right off the bat. Number one, 1%. Okay, anytime I've got a percent and I need it in an equation, I need to convert that percent to a decimal. I know that 1% as a decimal is 0.01. Okay, so that's one way I know I can eliminate h, because I know in this equation I would have a 0.01. Well, up here, my equation does not have a 0.01. All right, another way I know that I can eliminate h is this word discount. Okay, anytime I see that word discount, I know that that means subtraction. Okay, think about if you go to a store and you buy some stuff, but you have a coupon that grants you a discount off the total price. Well, when they take that discount, they're subtracting it from the cost to get your new total, right? So anytime I see discount, I know I'm subtracting. Well, in this equation, I'm adding. So I can eliminate h, which leaves us with j, but let's go ahead and work through it to make sure that is in fact our correct answer. So J says Brody rode his bicycle on 2 different days. The first day he rode 7 miles per hour and started 1 mile from his house. The second day he started from his house and rode 10 miles per hour. What is X, the number of hours that Brody would have to ride his bicycle to travel the same distance on both days? So I'm comparing the first day, or day 1, to day 2. They need to be the same or equal. So now let's fill in what we know about each day. So the first day he rode 7 miles per hour. Again, that tells me I'm taking that 7 and multiplying it by the number of hours, or our x, right? Our x represents the number of hours. So 7 times x, 7 times the number of hours. And started 1 mile from his house. So again, to get the total distance, I need to add that 1 mile. And that has to be equal to whatever he did on day 2. So day 2, he started from his house and he rode 10 miles per hour. So 10 miles per hour, or 10 times the number of hours, 10 times x. So we have 7 times x plus 1 equals 10 times x. Does that match what we have up here? It does. So our answer is J, or D. All right. Whew, that one was fun. All right. Here we're solving. So what value of x makes this equation true? Oh my goodness, I see some fractions in my answer choices. That's okay. We know how to solve equations. So here's my equation. 12 times x minus 15 equals 6 minus 3x. So I have an equation with variables on both sides. So the first thing I need to do is I need to get all my variables to one side of my equal sign. And to do that, we want to eliminate the side that has the least amount of x's first. So I've got a 12x here. I've got a negative 3x, because remember, a minus and a negative sign are the same. So I have a negative 3x on the right. I know that negative 3 is less than 12. So I'm going to cancel out this minus 3x first. Whenever we're canceling, we do the opposite, or the inverse operation. I know the opposite of subtraction is addition. So I'm going to add 3x here to cancel it out. And because it's an equation, we need to keep everything balanced. Whatever we do to one side, we're also going to do to the other side. So I'm going to add a 3x to the left side as well. So that minus 3x plus 3x, that leaves me with 0 x's. That's what we want. And over here, I've got a 12x plus 3x, which gives me 15 x's. So 15 times x minus 15 is equal to 6. So now I've got an equation similar to what we've seen last year, where I've got one variable here. So now I need to cancel everything that's on the left side. I need to get rid of my constant, this minus 15, and get rid of my coefficient, which is this positive 15 that's being multiplied by my variable. So the first thing we do is get rid of our constant by adding or subtracting. We do the opposite. Here I'm subtracting 15, so to cancel that out, I'm going to add 15. If I did it to the left, I also need to do it to the right. And we got to do a little math. Well, I know negative 15 plus 15 gives me 0. That's what I want. Get rid of it. 15 times x is equal to 21. All right. So now I'm multiplying my coefficient times my variable. So to get rid of my coefficient, again, I'm going to do the opposite. Well, I know the opposite of multiplication is division. So I'm going to divide each side by 15. 15 times x divided by 15 leaves me with just that one x. That's what I want. I want that x all by itself. 21/15. All right. Do I see 21/15? I do not, because we need to simplify our fractions. All right. Well, I know to simplify 21/15, I can divide each side by 3. Which then gives me 7/5. All right, do I see 7/5? Why, yes, I do. That is answer choice J or D. All right, so again, if you've got a fraction, always remember to simplify. We want to simplify those fractions. All right, let's move on. We got one more. All right, so Carnival M charges an entrance fee of $5.65 per ticket for the rides. Carnival P charges an entrance fee of $10.45 per ticket for the rides. How many tickets must be purchased in order for the total cost at Carnival M and Carnival P to be the same? All right, so some keywords that pop out: same. Tells me I've got an equation. Let's see, what are we comparing here? We're comparing Carnival M and Carnival P. All right, so Carnival M has to be equal to or the same as Carnival P. All right, now let's figure out what our variable is going to represent. So if, again, anytime I need to figure out what my variable represents, I want to go to the last question. That last question says, how many tickets must be purchased in order for the total at Carnival M and Carnival P to be the same? How many tickets? Do I know the number of tickets? We do not. That's our variable. So X is going to represent the number of tickets. All right. So now let's fill all our information in. What do we know about Carnival M? Well, we know Carnival M charges an entrance fee. Again, here's that word fee. That tells me I've got a constant, right? So a fee of $5.65 per ticket. Again, here's that word per. That tells me I'm multiplying. All right. So to get the total charge for Carnival M, we need to take our $5 entrance fee and add it, because remember, to get the total cost, we need to add our charges or add our cost. So 65 cents. So I need to take that 65 cents and I'm multiplying it by the cost per ticket. So 65 cents times the number of tickets. We don't know the number of tickets. That's our variable. So this time I'm going to use the letter T. All right. So 5 plus 0.65 times T, or $5 plus 65 cents times the cost of, or sorry, times the number of tickets. All right. So that all has to be equal to Carnival P. So let's see what we know about Carnival P. So Carnival P, they charge an entrance fee. Again, here's that word fee. That tells me that's my constant. So I need to take that $10. And they also charge a 45 cents per ticket. Again, here's that word per. So I'm taking that 45 cents and I'm multiplying it by the number of tickets. Again, we don't know the number of tickets. That's my variable. That's my unknown. So we're going to use the T to represent the number of tickets. And again, to get our total charge for Carnival P, we need to add the cost for the fee plus the cost for the rides, right? All right, so here's our equation. So 5 plus 0.65 times T is equal to 10 plus 0.45 times T. So now we need to solve it. So again, I've got variables on each side. I want to get rid of the side that has the least amount of t's, or the least amount of variables. Well, I know that 0.45 is less than 0.65, so I want to get rid of this positive or plus 0.45t. So to do that, I'm going to do the opposite. Instead of adding 0.45t, we're going to subtract 0.45t. And again, if I do something to one side, I better do it to the other. So again, here we're going to subtract 0.45t. All right, let's do a little math. These are going to cancel out. That equals 0. That's what we want. So here I still have that 5. We haven't done anything to that. I've got a positive 0.65 minus 0.45. Well, I know that leaves me with a positive, or plus, 0.20 times t, right? 0.65 minus 0.45 leaves me with 0.20 is equal to, we got rid of this, so all we have left over here is a 10. All right. So now I want to get rid of my constant, the number I'm adding or subtracting. So the number I'm adding or subtracting, okay, this time my constant comes first. That's okay. We still need to get rid of it first. So here I've got a positive 5, right? So I know to get rid of a positive 5, or to cancel out that positive 5, I'm going to subtract 5. All right, so I'm going to subtract 5 here. If I do it here, I better be doing it here. So now let's do a little bit of math. Those cancel out. That gives me 0. So I'm left with a 0.20 times t. Wow, that is an ugly t. All right, sorry, that's the best I could do. 10 minus 5 gives me 5. So now I need to get rid of this 0.20 or 0.2. Well, that's being multiplied by t. So to cancel it out, we're going to do the opposite, which is divide by 0.20 or 0.2. There's my decimal. Again, whatever I do to one side, I better be doing to the other. So I'm going to divide this by 0.2. So 0.20 times t divided by 0.20 leaves me with just that 1 t. Whoops. Trying to write an equal sign. I'm getting ahead of myself. All right, so we've got that t is equal to, let's see, I can't do that in my head, but I'm in the 8th grade, so I can use a calculator. If I do 5 divided by 0.20 or 0.2, I get 25. All right, so how many tickets must be purchased in order for the total cost at Carnival M and Carnival P to be the same? 25 tickets. Do I see a 25? I do. It's answer choice A. All right, good job.